everyone. Today I'm excited to bring to you a topic where we are going to discuss the vaccine. Okay, the main reason why we are discussing about the vaccine, we want to understand how the COVID-19 vaccine works. We also want to understand the development of the vaccine. And to discuss this lesson, the way we are going to move about it is that we are going to look at the vaccine, we look at the vaccine process, and then we also look at the immune defense system. Okay, so this will be the first part of the lesson where we're going to look at the vaccine process. We're going to look at the immunity or immune system defense or immune defense system. And then afterwards, we are going to look at the development of the vaccine, the stages that are involved in the development of the vaccines. Then apart from that, we are also going to look at the types of vaccines. Okay, we're also going to look at the type of vaccine and see where the vaccine for COVID-19 also falls and what is there for us. Okay, so on the other part of my board here, we're going to discuss the COVID-19 vaccine, how they work, and we're going to look at which category they come from. So our emphasis mostly is how they work. We are not going to do on the efficacy of the drug. But what I need to mention is that there is no vaccine which is 100% safe, and the information that I've gotten from literature about these vaccines is that they are safe, based on everything that I'm going to explain on how these vaccines have been manufactured. We'll be able to make that judgment. And I have also good news at the end of the presentation concerning the other vaccine, okay, which has also been developed, and what it entails for the future as to what other vaccines may be possible so that we prevent diseases. So to start the discussion, let's look at, let's define what a vaccine is. So a vaccine is a suspension of microorganism that induces antibody production in order to fight specific diseases. So a vaccine is more of an antigen or a pathogenic substance that, if introduced in the body, is going to evoke formation of new antibodies specific to that disease. Alright, okay, so now, what is the vaccination process? Let's look at the vaccination process. So looking at the vaccination process here, what we have is that when an antigen, a microorganism, okay, that is able to cause an infection has been introduced in the body, okay, so it can be introduced by inoculation in the body. So what we necessarily mean here is that there are sometimes infections that get entries to our body, that get entries. So now here, since we're talking about the vaccine, mostly they are inoculated within our body. And like the way we acquire diseases through inhalation, through what we call fecal oral route and the likes, there, here we are inoculating. For vaccines, we inoculate through injections, okay, through giving vaccines by mouth, okay, so we do that. So what we are saying is that this antigen or pathogen can be introduced through the process of inoculation into the body. So when it has been introduced in the body starts to build antibodies and memory cells to fight the infection. So there is a very big process that we will now start when this antigen has been introduced in the body through inoculation. The body is going to recognize this as an infection, and it's going to build memory cells for this specific infection so that in future the body will be able to fight this infection. So it will develop immune cells, that is antibody, and memory cells to fight the infection. Alright, so the body is now immune when it has developed these antibodies and memory cells. So the body now becomes immune. Okay, so the body becomes immune because it assumes what we call an adaptive immunity. The body is going to assume an adaptive immunity. It's going to adapt to these foreign proteins so that in future, when such proteins are introduced within the body through any other ways that we can acquire, the body is going to evoke an active immunity to this infection because it has adapted. So this adaptive immunity can either be passive immunity or active. Okay, and what we need to know is that passive immunity can either be artificial or natural, and active immunity can either be artificial or natural. Alright, so now let's look at the body's immune defense system. So the body's immune defense system is comprised of two segments. The body's immune system is comprised of two segments, okay? So you may ask, what are those two main components that our body immune system is comprised of? So it is comprised of the immune defense system, and it is also comprised of the adaptive immunity, okay, which is the specific immune response. Alright, so now when we talk about innate defense system, we are necessarily looking at two aspects. That is the external. So the external part of our body's immunity is the skin. Any break in the continuity of the skin compromises the body to get infection. Okay? So the skin, the mucous membrane, we find that a lot of opening, a body has got these opening cavities that are lined with the mucous membrane. Within that mucus, there are enzymes that are able to kill the bacteria if at all they come in contact with this. So we have this external part of our immune system. Okay, this is the external part of our immune system. So we have the skin, the mucous membrane. Mostly skin forming the barrier, and then the mucous membrane. Then we have the internal parts of our defense system that falls under the innate defense system. Okay, so we have the internal. So when I talk about the internal defense system, mostly it's about the process of inflammation. Because within a tissue, we have stationed white blood cells that are known as the macrophages. Okay, so we have macrophages, and we can also have antimicrobial proteins. Okay, so we have stationed macrophages that are going to kill any invading microorganism or substance that may be introduced in the body by the process known as the phagocytosis. Okay, so phagocytosis, the cell will engulf the bacteria and inside form what is known as a phagosome. It will kill the bacteria and release non-toxic proteins within the body after neutralizing the bacteria. So that is what happens in the internal immune system. But now, if the macrophages fail, they detect that the battle of the infection that has come is big. Okay, it's going to trigger an inflammatory system by activating a cytokine release or cascade, so that the other cells are activated to come and fight the infection. So that is within the internal defense system of the innate. Okay, so the internal is mostly about inflammation, and the process of phagocytosis by the stationed white blood cells known as macrophages are the first ones to attack the infection that comes within the tissue. Okay, so in internal, we are saying we have antimicrobial proteins and phagocytosis. So the blueprint under internal defense mechanism is inflammatory process. Okay, so now that takes us to adaptive or specific immune response. Okay, so adaptive or specific immune response. With adaptive immunity, it has two levels. There is humoral immunity and there is cellular immunity. So when we talk about humoral immunity, we are necessarily talking about this immune system that is built on antibodies, where we have got these B cells that are fighting the infection. And then when you're talking about cellular immunity, we are talking about specific cells that cellular immunity, specific cells that come now to fight the infection. Alright, so here we were trying to review the immune system.
Okay, immune defense system. So under the immune defense system, we have the innate immunity and we have the adaptive immunity. So now these are complemented by what we call complementary defense system. Okay, so if you want to know more about immunology and the likes, there's a video that I've also recorded on immunology, and I've talked about all these things. So innate immunity and the adaptive immunity, they are also complemented by complementary immunity. Okay, so when looking about on the vaccine, we have defined what a vaccine is as a suspension of microorganism that induces antibody production to protect against disease. And we have also looked at the vaccine process, where the antigen is introduced, then it is inoculated in the body. The body builds an immune system. Okay, and when the body has built an immune system, it now is able to defend itself. Okay, so now let's look at the development of a vaccine. First, the main aims of developing a vaccine is that we want to bring something that is, the primary aim of coming up with a vaccine is that we want to bring something that is safe. So we look at the issue of safety when we are developing a vaccine, and we also look at the issue of efficacy. Okay, so in looking at efficacy, we can look at it in two things. Should be able to protect, it should be able to protect you from the disease that it purports. Okay, that it purports to be made for. Okay, so that is to do with efficacy, and it should also prevent infection. So when you take the vaccine, okay, we would want you to have less severe form of the infection, because the body has developed an immune response. So you should not have a severe infection because you have been immunized. Okay, so when a vaccine is being developed, we want it to be safe in the human being, so that when it is administered, it does not cause adverse reaction. Okay, it does not cause effects that are going to kill you. Instead of the virus killing you now, the vaccine kills you. No, we want the vaccine to save life. So we look at the issue of safety and efficacy. We want it to protect you from the disease, and we also want it to prevent you from having the severe form of the disease or not having the disease at all. Okay, so now let's look at the development of a vaccine. Okay, so development of a vaccine, I would say it is in, theoretically I would say it is in two stages. There's the preclinical phase and there's the clinical phase. Okay, so now when we say preclinical phase, this is the phase where all experiments are just done on animals. That's the preclinical phase. And then when you talk about clinical phase, okay, clinical phase is broken down into 4 phases. So you find that in some documentation they will talk about preclinical phase and then talk about phase 1, 2, 3, and 4. Okay, so now let's understand what is involved in each and every phase. So when you talk about phase 1, okay, of vaccine development, here in phase 1 now, clinical, we are testing in human beings. So the first human beings in which we test the vaccine are healthy human beings. Okay, so we test this in healthy human beings. They should be less than 100 healthy human beings with no underlying morbidity. Okay, they should not have any diseases. So why we are testing here is to know the side effects of the vaccine, okay, or the drug, because it's necessarily about drug development. So we want to know the side effect of the drug, and we also want to establish the dose. Okay, this is the upper limit and lower limit. So we want to come up with the therapeutic index of the dose. So we want to come up with the dose of the drug. Okay, so the upper and lower limit, so that we can come up with the therapeutic index or the therapeutic dose for the drug. So in phase 1, the individuals that are being used, they do not have a disease. Okay, so now that takes me to phase 2. Phase 2, we try to match the vaccine or the drug that is being developed with the demographic data of people that have the disease. So in here, you are going to use 100 to 1,000 people, okay? And here, because you are targeting the people that have the disease, you are trying to also establish the side effects and the dosage, okay, and see how it affects people that may have some other comorbidities or that may have other diseases. So you have a population of 100 to 1,000 where you administer, and these people may have comorbidities, unlike in phase 1 where they do not have a disease. Okay, so now that takes me to phase 3. Phase 3, most of the vaccines that are being used right now, most of them, they are under phase 3, or I would say they are under phase 4, because they have been given an emergency use authorization to allow to see if it's going to help humanity. All right, so phase 3, you have 1,000 to 10,000 of people that you are going to use the drug on. But here you're also trying to establish the side effects. You're also trying to establish the dose. But what is important in stage 3 is that we also have a control group. Control group can be given like a saline, something that is neutral, okay, that might not cure the disease, but something which is neutral, to find out whether psychologically, okay, so like we have a placebo group, that is what is called placebo group or control group, okay, where they are just given things like saline, okay, and then the other one are given the actual drug. So in phase 3, we want to see those people who are given the drug, if at all they are really responding to the drug, or there's just that placebo effect to say, okay, I've been given the shot, so now everything is okay. So there's that psychological feeling. So we want to rule that one out by seeing whether the drug is actually working. Okay, then phase 4, here we look at authorization. So most of the drugs, the vaccines, okay, we have within a calendar developed 3 vaccines to help save humanity. So here, this is where you give emergency authorization through the Food Drug, okay, agency. They can give you an emergency authorization of a drug to see if it's going to help save lives. Okay, so with that, we have looked at the development phases of the drug, okay, of which I said there's a preclinical and the clinical phase. The clinical phase is you are doing tests in human beings. The preclinical, we are doing tests in animals. Okay, so in the clinical phase, we have 4 phases. That is phase 1, 2, 3, and 4. Phase 1, healthy individuals are used. You want to establish side effects. Then phase 2, you use 100 to 1,000. You are looking at the side effects, and these people have comorbidity in phase 2. Then phase 3, you have 1,000 to 10,000, and you have a control group, people that receive a placebo, okay, to see whether psychologically people, when they are given, there's this thing which is just helping them psychologically to feel, no, they have become immune, or you want to see if the drug is actually working. All right, so after that, there is phase 4, which is the authorization. Of course, you find that other documentation, they also talk about phase 5, which is post-marketing, okay? But a lot of literature, they try to ignore that. But post-marketing is also very important for pharmacovigilance, to see if at all the vaccine is also helping, or that drug is also helping for other things that people cannot. Okay, so now that is to do with the development of the drugs. Now let's look at the types of vaccines. So we have the following types of vaccine. We have live attenuated vaccine. Okay, so now live, okay, something has not been killed, okay, but attenuated, it has been weakened. So here, a live attenuated vaccine is a weakened vaccine or microorganism which has been weakened, okay, incapacitated, but it is live. Okay, one thing you need to know is that live vaccines are not advisable to give to pregnant women, okay? So live attenuated, we are looking at a vaccine, okay, the whole vaccine, okay, because when we're talking about vaccine types, we have the whole agent, okay, and we have the subunit. So when you're talking about whole agent, live attenuated and inactivated vaccine, they fall under the whole agent vaccine. And then after that, we have subunit vaccines. So the two main types of vaccines is whole agent type of vaccine, where attenuated and inactivated fall. And then we have subunit vaccine. Okay, so live attenuated vaccine, examples of vaccines that we have that are live attenuated includes the MMR, that is measles, mumps, and rubella vaccine. And we also have the oral polio vaccines, and we have BCG vaccines. So these are made from live attenuated weakened vaccines. Okay, then we have the inactivated vaccine. So this is the killed version of the vaccine, okay? This is a killed version of the vaccine. So here in the inactivated vaccine, the killed version, what you need to know when you're looking at the difference between live attenuated and inactivated. For live attenuated, you may just need 1 or 2 doses. For live attenuated, you may need just 1 or 2 doses. But for the killed version, you may need a lot of doses in order for you to acquire immunity. You may need a full doses. Examples of inactivated vaccine includes the inactivated polio vaccine, okay, hepatitis A, rabies. So those are the examples of inactivated vaccine. Okay, so I've mentioned that inactivated vaccine and live attenuated vaccine, they fall under whole agent vaccines. So they are known as, they fall under whole agent vaccines. Then we have subunit vaccines. Or these subunit vaccines, they can be made of, let's say, conjugates or recombinant particles that may help in invoking immunity within a human being. So we have subunit vaccines. So apart from subunit vaccines, there we have DNA vaccines. So DNA vaccines, mostly these being done on laboratory basis, but during the COVID and the likes, there is one DNA vaccine that has been developed. Okay, so we have the subunit vaccines, we have the DNA vaccines, and we have toxoid vaccines. Okay, so toxoid vaccines here, they neutralize the toxins that a bacteria has produced, or the microorganism has produced. So we have the toxin vaccine. So here we are necessarily looking at the types of vaccines, of which we have said there is whole agent vaccine and there is subunit vaccine. Whole agent, we have attenuated and inactivated. And then we have the subunit vaccine and DNA vaccine and toxoid vaccines. Okay, so now our main part of discussion has to do with the COVID-19 vaccine, understanding how the COVID-19 vaccine works. So we have the Modena Vaccine, we have the Pfizer Biotech Vaccine, okay, and we have Astrozeneca Vaccine. These are the 3 vaccines that have been produced within one calendar. Okay, so against COVID, so that have been given an emergency use authorization in order to save humanity. Okay, so now when we talk about Modena vaccine and Pfizer vaccine, these are mRNA vaccines. When you talk about Modena and Pfizer vaccines, these are mRNA vaccines. So these are subunit vaccines, okay? Because they have just taken a certain unit to help evoke immunity in the human body. But when you talk of AstraZeneca vaccine, okay, this one is a DNA vaccine, okay, which has been encased in a chimpanzee adenovirus. And the casing for the Pfizer, okay, and Modena vaccine, the principle is that they are encased so that the mRNA does not get destroyed before it reaches the cell. It is encased in a nano phospholipid. It is encased in that so that the mRNA is delivered to the cell. Okay, so now I have a bit of a drawing here. This is the COVID vaccine, and here is the nucleus, and then we have the cytoplasm, and there is an imaginary kind of cell wall against cell membrane against this same drawing. There's an imaginary cell membrane. Okay. So now, when you give Modena, okay, or Pfizer biotech vaccine, what it is that since it's a messenger RNA vaccine, it does not enter the nucleus. It does not enter the nucleus, because what necessarily happens is that any information that is within the cell cytoplasm that will enter into the nucleus, it is transcribed, okay, it is transcribed into messenger RNA through the process known as transcription. And then it goes and through the ribosome or endothelial reticulum, through the ribosomes there, it is the process of translation of these messenger RNA to amino acid is going to happen, and the COVID vaccine, the COVID virus, is taking advantage of this process of translation in order to come up with amino acids that are necessary to build another COVID virus, so that the virus is now going to invade and proliferate within the cell. So now we have come up with an mRNA vaccine that tries to tamper with this process of translation, so that the virus does not take advantage to come up with amino acid that is going to build amino acids that are going to help the virus to proliferate. But now this mRNA is expressed on the cell membrane. Okay, this is expressed on the cell membrane. Okay, that is on the MHC complex 1 and MHC complex 2. Okay, so when you talk about the MHC complex, this one, that is complex 1, it has to do with lymphocytes, that is CD4 and T helper cells that come here in time when there's an infection in order to guard against infection. And then the MH2 receptor is for CD8 and cytotoxic cells that come when you are fighting an infection. So now, what happens is that when someone has gotten the vaccine, it will not enter there. So this mRNA component of the vaccine is going to be expressed on the cell membrane. So when it has been expressed on the cell membrane, what will happen is that the B cells, okay, are going to proliferate to become plasma cells, okay? And when they become plasma cells, they're going to help to build antibodies. And it's these antibodies that now go to block the spike. So because the mRNA protein has been taken from the spikes, these are the spikes of the virus. So it is going to break the fusion of the virus to other cells, because antibodies have been formed and these antibodies have been activated in order not to allow the virus to start attacking the body. Okay, so the B cells are going to proliferate to become plasma cells. Okay, plasma cells will produce antibodies that are going to block the spike, okay, the spike proteins that are found around the coronavirus or SARS-2. Okay, so now this blocks the process of the virus infecting other cells. So this is necessarily how the vaccine. Okay, so now to give a summary on the COVID-19 vaccine and how the vaccine works, what we are saying is that when we're talking about Modena and Pfizer, these are mRNA vaccine, and Modena in terms of storage is favorable, it's economically favorable because we have a lot of capacity to store this, and it's easier to transport. Okay, so for all the vaccines, you need about 2 doses. Okay, for you to achieve full immunity, you need about 2 doses. Okay, that is on day 0 and on day 21 or day 28, depending on the vaccine that you are taking from here. Okay, so they all need you to take 2 doses. Okay, as I indicated earlier, that live vaccines, when you're talking about pregnant women getting the vaccine, that is the live, we tend not to give because we don't want infection to go and affect the baby if at all it does not affect the mother. And the other thing is that you should know that when a woman is pregnant, the immunity is a little bit low. So getting the COVID-19 vaccine may be safe because we are not using a live vaccine. Okay, it may be safe based on that principle that we are not using a live attenuated vaccine. It may be safe to give to a woman who is who is pregnant. Okay, so among those vulnerable groups. Okay, so Modena and Pfizer Biotech, these are mRNA vaccine. Okay, so they come to interfere with the process of translation so that the virus, the COVID virus, this one here, okay, because it has been coined using the spike proteins. So these are the spike proteins. That's why I was saying, if you are not specific in testing for COVID-19, okay, and someone may have a pseudo positive for spike proteins. Okay, if your PCR is not specific, but if it is specific, you try to check for nucleocapsid presence, and if it is positive, it means that person is positive for COVID-19. Okay, so here it will help to interfere here so that the necessary proteins that are needed within the cytoplasm are produced. But it is also going to be expressed on the cell membrane, that is the MHC1 complex. With MHC1 complex is target CD4 and T helper cells, and when we talk about MHC2 complex is cytotoxic cells and CD8 cells. Okay, you can also look at the other topic recorded on hematopoiesis, okay, where I talk about the division of these cells, okay, and what they do. Okay, you need to know that these T cells, you know, they may produce cytokines, and in COVID there was this cytokine storm. No matter how your immunity is, you know, the infection was coming so much that the body became overwhelmed to protect itself. Okay, then when you talk about Astrozenica, the DNA vaccine, also this is a positive development that we are now something which was just at experimental level. And when I talk about experimental level, for decades, okay, for decades within the laboratory, they have been experimenting how a vaccine can be made. Okay, of these subunit vaccines, we have the pneumococcal conjugate vaccine, we have influenza vaccine. Okay, so the part which was working was the issue of the DNA vaccine. So if we are now able to make a DNA vaccine, there is hope that the HIV vaccine can be found. Okay, of course it may be specific to an individual, and then every individual. Okay, we are hoping that we can have that specific DNA vaccine also for HIV. That is where a lot of hope is in coming up with a vaccine. But also the disease, when you look at the gravity of it and how people have been affected, more resources are there. That's why this DNA vaccine has received a lot of funding, so that we have seen this coming. Okay, my hope is that also in HIV pumping, we need to pump in a lot of money so that we can come up with either an mRNA vaccine or a DNA vaccine for HIV, because HIV affects all, doesn't choose race. Okay, just like any other disease can affect any person, does not choose race. So the good information and message that I had for you is that if we can have a DNA vaccine and we can have a messenger RNA vaccine, okay, of which mostly for decades these have been experiments in the laboratory. It is possible that we are going to develop a lot of vaccines for these other newer diseases that are there, because there was adequate funding to promote this. So what my feeling about the COVID-19 vaccine is that since we are using a subunit, it's not necessarily going to cause an infection. Okay, it's going to help build an infection, your body as immune system. And a lot of people from the experiments and the data is that a lot of people who have been vaccinated, they are having a less severe form of the disease, which is going to be very, very helpful. Okay, so that is on the COVID vaccine, COVID-19 vaccine, how it works, the vaccines that are there, the storage, and the number of doses that someone is expected to receive. Okay, then in starting our lesson, we looked at the vaccine, defined the vaccine, we looked at the vaccine process, okay, where we looked at in the vaccine process that we have an antigen, which is inoculated. After being inoculated, we have the body building its immune or antibodies against that specific infection. And when talking about specific infection, is that when you get one vaccine does not mean you have become immune to all diseases. The body has a system that it will develop specific immunity against that specific infection, okay? When it's as it develops these memory cells and antibodies against the infection. So today we may have coronavirus, tomorrow we may have other diseases. Okay, it's important that our body needs to develop immunity, whether artificially or naturally, against this infection, because the body has got a specific way it works against this infection. So, in a nutshell, that has been the summary on our lesson today, okay, where we also looked at the development of a drug, okay, and our main concentration was the development of the vaccine. So, development of the drug, the stages that are there, which is preclinical and clinical. Clinical is taken as phase 1, 2, 3, and 4. Okay, and then we also talked about types of vaccines. Alright, so that is our lesson on vaccines, the vaccine process, and the COVID-19 vaccine. Please remember to put up the mask. These things are there to help us in protecting us against infection. When you look at the immune system and defense, you find that these mucous membranes on our face, we can help them by putting on a mask, and washing is very, very important in preventing COVID-19. So let's wash, let's avoid overcrowded places, because from there you can easily get respiratory infection. So please, it's through effort by each and every individual that we can win the fight against the coronavirus and go back to normal life. Alright, so thank you very much, please. Thank you.